mp4 Arithmetic Series. Okay, Arithmetic Series. And the difference, again, we did this yesterday. A sequence is just a list. A sequence is just a list. So like 1, 3, 5, 7. That's a list. That's yesterday's work. Today's work, series, is a sum. 1 plus 3 plus 5 plus 7. Right, we're actually adding things up. We can actually figure this out. Let's see, that's 4, 9, 16. So this is what we're doing today. We're doing the sum part. We did the list yesterday. We're doing the sum today. And I left you guys with a question yesterday. Here's kind of the thing. If you can remember how to do this, you can remember how to do these. Okay? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, 11, 12, 13, blah, 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 98, 99, 100. And the teacher asked everyone to do this, expecting them to take hours. And the little boy came back in a few seconds and answered the question. Oh, it's 5,050. How do we do that? How did he do that? Does anybody have an idea? There's some kind of pattern. There's some kind of explicit formula lets you jump to one term, right? But we want to know if I add them all up. There's a pattern. There's a pattern. Anybody see it? It's kind of hard. He figured it out instantly, which, I mean, he's one of the greatest mathematicians. The answer is 5,050. Let me give you a hint. That's my hint. But you need to add the other ones too. 4 plus 5 plus 6 plus 7 plus 8 plus 9. Exponent. That's the same number multiplied over and over again. Anybody have an idea? No. This is before calculators were invented. Anybody have an idea yet? Okay. Anybody have an idea how we can use that mysterious bit of writing that I'm doing here to figure out the answer to all these? There was no Google back then. There was no Google when you were born. Come on now. Yes, okay, he had Yahoo, but it wasn't good back then. Junior? No. Shh. Bye, guys. All right, sorry, I can't hear. Sorry?
Did he add like 1 plus 100 and then etc. and then add those?
Okay, yeah, you're on the right track. What's 1 plus 100, guys? What's 2 plus 99? What's 3 plus 98? What's 4 plus 97? What's 4 plus 97? What's 5 plus 96? What's 6 plus 95? So the question is, we've got that. What's the other key question we need? How many different pairs are there?
50.
There's 50. How are we getting 50? There's 100 terms, right? Half of that is 50. So basically he took 101, right, because you keep pairing them up, times the number of pairs, which is 50. So 101 times 50 gives you 5,050. 5 years old.
And who was this mysterious kid now?
Oh no, he's dead. He was in the 1700s. Yeah. Gauss.
Oh wow. Give me all this.
So he was one of the greatest mathematicians of all time. So don't worry. Yeah. Gauss. 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 Involved in tons of different mathematics. All right. What did he do? He said, all right, I'm going to take, I noticed that this always adds up to the same thing, right? Take the number of pairs, which Juwan said was 50, right? Basically, he took 100 divided by 2. And I'm going to multiply. So multiplied by, notice how it always gives you the same, right? 101, 101, 101, 101, 101. It doesn't matter. So I'm just going to take the first one and the last one, right? That's 101. So the first plus the last. Right? So that was 1 plus 100. So basically, he got 50 times 101, which is 5,050. And he got a cookie. No, I don't know what he got. 5,050. If you can remember what that boy did, Gauss, if you remember what he did, you can solve any of these problems. You just got to remember these steps. Take the number of pairs, multiplied by the first plus the last. That's all you got to do. The number of pairs times the first plus the last. The problem is sometimes you don't know this one, or you don't know this one, or you don't know this one, but that's where our work yesterday comes into play. So let me give you what this is in the formula. So the sum of an arithmetic series. Remember, series means sum. Sum of arithmetic series is, we call it S sub n. So I'm summing. It's S, not A. S sub n equals. Again, we're going to take, what did Joanne help us out with? If it was 100, we didn't use 100. We said 50, right? In other words, we took the number of terms and we divided it by what?
2.
We divided it by 2. We cut it in half, right? This is the number of pairs. Number of pairs times the first one. We know what to call the first one. We call that A sub what? A sub 1 for the first one. And then the last one is, you're correct, A sub, well, for 100 for this one, whatever it is, it's going to be n, whatever we want. This is just the formula. All right, this is the first, this is the last. If you remember this, you'll be good to go. The number of terms over 2, so that's the number of pairs, times the first plus the last. That's exactly what he did. Right? He took 50 times the first plus the last. So let's try some of these. Number 1, let's sum. Let's sum up letter A. Let's do 2 plus 11 plus 20 plus 29 plus 38, he agrees, plus 47. 2 plus 11 plus 20 plus 29 plus 38 plus 47. Well, we'll just do it exactly, just pretend you're back when you're 5 years old. And take it exactly how he did it. Okay, he said, all right, I'm going to sum up. How many terms do I got here anyway? 1, 2, 3, 4, 5. This is A sub 6, right? A sub 1. So the sum of all 6 would be, I've got not 6. How many different pairs? If I match these guys up, guys, how many different pairs do you have? You have 3 pairs. So 6 over 2. 6 over 2 pairs times, and remember, it's always going to be the same number, guys. What is this number always going to give you? 47 plus 2 is the same as 11 plus 38 is the same as 20 plus 29. What number is that? 49. But we'll just use the first one plus the last one. 2 plus 47. If you can remember how to do this, again, that's the whole key to today. So we have 3 times 49. 3 times 49, which is, well, 3 times 50 is 150, right? 3 times 50 is 150. Take away 1 3 from that, we get 147. 147. Okay, so really all you got to do is do the number of terms over 2 times the first plus the last. Let's do a couple more together. So I know this just takes practice. I'm writing over my wife's stuff. Okay. Recess. All right, here we go. Letter B. Let's sum up 1 plus 2 plus 3. This time I'm not going to give you all the middle terms, blah, blah, blah. Plus 2,999 plus 3,000. 1 plus 2 plus 3 plus 4 plus 5 plus blah, 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 all the way up to 2,999 plus 3,000. So we know that we're trying to sum up, it looks like, what's our D here, guys, if we were adding these up? How much are we going between each term? 1. So we know that we're not skipping any terms. We know there's exactly 3,000 terms. There's 3,000 terms. So if I was to pair them up, pair you up, pair you up, pair you up, I'm going to split this. How many pairs would I have? You would have 1,000, how many? 500. So in other words, 3,000 over 2. Right? That's the number of pairs. And if you look, if you add up the first and the last, or the second and the second to last, or the third and the third to last, you're always going to get 3,001. Right? I should have written that as 1 plus 3,000. 1 plus 3,000, which is 3,001. So we get 1,500 times 3,001. And I'll just write this out for you. So it's going to be 3,000 times 1,500 would give us 4,500,000. And we add the 1,500 there, so we get 4,501,500. Same process every time. Why don't you guys try one? 10 plus 20 plus 30 plus blah, blah, blah. And why don't we end it at 70? So the question is, so far, guys, so far, it's worked out nicely because we've always had an even pair, right? We've always had an even number. Look at this one. 10, 20, 30, 40, 50, 60, 70. How many terms you got for this one, letter C? 7. 7 pairs. So if you split it, you're going to get an odd number of pairs. Is that going to work or is it going to fail? Is the formula going to work if you have an odd number of pairs, like a 0.5 pair? Well, try it. Just try it. So why don't you guys try this? Go and use the formula. See what you get. And if you have time, add them up just manually. See if you get the same answer. All right, guys, let's take a look here. So how many different pairs do we got here? We're going to take, how many terms do we have total? 7 terms. 7 terms. So how many pairs? 7 divided by what? 2. So you have a fraction or a decimal worth of pairs. You have 7 over 2. 7 over 2 pairs. And I'm going to add up the first one and the last one. 10 plus 70. You could have done 20 plus 60, 30 plus 40, same thing. Or 30 plus 50, etc. So we have 3.5 pairs. 3.5 pairs of 80. 3.5 pairs of 80. Well, what is this? Break this down. 3 times 80. 3 times 80 is 240. I'm going to break this down. 240. 0.5 times 80. What's 0.5 times 80? What's half of 80? 40. So 240 plus 40 gives me 280. Notice that's the exact same thing. I kind of did this really small over here, but if you add it up, you get 280. So this is correct, 280. Who was able to get 280 by adding these up? About half of us. All right.